welcome to Periodical News, where we bring you the latest updates on groups, trends, and elements of the periodic table. Our top story tonight, the alkaline earth metals. For those of you just joining us, the alkaline earth metals consist of magnesium, beryllium, calcium, strontium, barium, and radium. While the earth metals are similar to their counterparts, the alkaline metals, they each have their own trends. Take, for example, one of the more popular trends, which is their reactivity. You know, those alkaline earth metals reacting to everything. Now, each successive element in the group, starting from top to bottom, has an extra electron shell with one electron. This is not the most stable form for the atom, so we want to lose that electron. And the fact that they have low ionization energy, they lose it pretty quickly, hence their tendency to react violently to many things. They are, in fact, the second most reactive group of elements in the periodic table. Just in time for physical and chemical properties. Let's see here. The earth metals, unlike the alkaline metals, whose boiling and melting points decrease with an increase in atomic number, the earth metals have a not so clear pattern, so to say. Take, for example, beryllium, with the lowest atomic number, but has the highest melting and boiling points of the alkali earth metals. Their points are higher than that of the alkaline metals because of their smaller atomic size. And as far as chemical properties are concerned, they can lose electrons easily and are very reactive. Take calcium, for example. It reacts slowly with water because calcium desires to rid itself of that extra electron in order to become more stable, and in the process forms calcium hydroxide and hydrogen gas, hence their reactive nature of many things. Magnesium might be an exception to this because it does not react well with water, and it is in fact inert to it. That was a nice commercial break over there. Props to you guys. Anyways, the electron configuration of the earth metals is Ns squared. Atoms form ionic bonds because they either want to gain or lose an electron in order to become more stable, which is something that all atoms aspire to, and something that we should all, as people, aspire to as well. The earth metals, which generally have an extra electron, desire to rid themselves of it, hence their reactivity to most things. For our final scene, which is the special elements. We're starting off with radium, which belongs to period 7, group 2, block S, atomic number 88, and it's usually found in a solid state. Now, it is a soft, shiny, and silvery radioactive metal. Radium now has actually few uses because of its radioactivity and expensiveness. But it is sometimes used to treat prostate cancer that has spread to the bones by releasing alpha particles to kill any cancer cells. Radium was also once used in luminous paints, in clocks, and watch dials, but although alpha rays cannot pass through the glass or metal casings, they are now considered too dangerous to be used in this way. Radium was discovered in 1898 by Marie Curie and Pierre Curie. They managed to extract 1 milligram of radium from 10 tons of the uraninite ore. And it's a very difficult and laborious process. Fun fact, in the presence of air, it tarnishes into black. Now we move on to beryllium, period 2, group 2, block S, atomic number 4, and it's usually found in a solid state. Beryllium is a silvery white metal which is relatively soft with low density. It is used in gears and cogs, particularly in the aviation industry. It is used in alloys with copper and nickel to make gyroscopes, springs, electrical contacts, and used as structural materials for high-speed aircrafts, missiles, and satellites. The gemstone beryl and emerald are both forms of beryllium aluminum silicate. The French mineralogist Abbé René just why? French have very confusing names. Thought that he might have discovered a new element, so he sent those rocks to Nicolas Louis Lacouille, French. To analyze them, they sure enough had a new element, which was announced in 1798. Forgive my pause, ladies and gentlemen. Blacking out, blinking out. Sorry. Stressful day at work. Fun fact, beryllium is mainly used in military, so its uses are not fully well known, and it can be traced from the Sanskrit language, which used to be the name of the city of Belur, which sounds like beryl, beryllium. Yeah, that makes sense. Now on to calcium, which is something that everyone loves and everyone needs. It is period 4, group 2, block S, atomic number 29, and is usually found in a solid state. Calcium is a silvery white soft metal that tarnishes rapidly in air and reacts to water, sometimes violently. It can be used in plasters and steels to remove impurities and is essential in living things for the growth of healthy teeth and bones. Bones are actually mainly composed of calcium phosphate, and the average human contains about 1 kilogram of calcium. In 1808, although calcium was suspected of existing, there was no direct proof. But enter Humphrey Davy, who tried to reduce moist lime by electrolysis. He was unsuccessful the first time, but after many more tests, he finally added sufficient lime into his mixture and produced more of the specific amalgam, which is a mixture from which he distilled off any of the remaining mercury, leaving just the calcium, finally proving that calcium did in fact exist. Although it was used many times before since the Romans to make concrete, buildings, etc., there was no direct scientific approach or proof to discover that calcium existed until Humphrey Davy came along. Fun fact, pure calcium can react violently with water, and calcium is the 5th most abundant element in the Earth's crust. Now on to our final special element, magnesium. Good old magnesium. Group 2, period 3, block S, atomic number 2, and it's usually in a solid state. Magnesium is a silvery white metal that ignites easily in air and burns with a bright light. It improves the mechanical fabrication and welding characteristics of aluminum when used as an alloy agent. Added to iron and steel to remove sulfur, and is used in fireworks because of its intense reactivity. Magnesium is also necessary for plants to survive because it is a necessary and fundamental component to chlorophyll, and without chlorophyll there can be no life, and without no life there can be no humans and no me. Can you imagine? No me? Who will be telling you this news now? Certainly not me. Fun fact, First, our history. We cannot ignore history. By ignoring history, we are doomed to repeat it. Life lesson there. The first person to recognize that magnesium was an element was Joseph Black at Edinburgh in 1755. Fun fact, it is the 8th most abundant element in the Earth's crust and the 9th most abundant element in the universe. And, well, sadly, that's all the time we have today, folks. I hope you are now a lot more informed on the alkaline earth metal. Tune in next week for the transitional metals. Cut.